AC and DF are the chords of a circle. So I'm going to label two chords, and one is the chords AC. Remember, chords are straight lines. Yeah. And then DF also. I'm not going to draw a DF here that quick because I'm going to read it with the layer part. So center of the circle O is the intersecting point of the chords A, C, and DF. So we can conclude that we have a chords DF here, and then the intersecting point is the radius, is the center of the circle O. So I'm going to label it as O. So, and then B is the point on AO. So I'm going to label it as our B. So, and then E is the point on OF. So I'm going to label this as our E. And then if angle COD is equal to 30 degrees, label it as well. And the area of triangle COD is equal to 21 square units. I'm going to draw a triangle here. This is 21 square units. Its area is equal to, yeah. And then find the value of CD. So we are going to find what is our CD here. And then given AB is equal to 1, OB is equal to 2, and then EF is equal to 3, OE is equal to 4. So here I'm going to draw it clearly, write clearly, 2 and O here. This point is O. So because we have an intersecting point here, and then we have two chords, so we can use our intersecting chords theorem. So the length of this, the length of AO times the length of OC is equal to the length of OD times the length of OF. So OA, which is equal to 1 plus 2 here. OA is equal to 1 plus 2 times OC. This time OC, we don't know what its answers. So 1 plus 2 times OC is equal to our 3 plus 4. This length times this length, same as this length times this length. So 3 plus 4 times our OD here. So we are going to get OC divided by OD is going to be 3 plus 4, which is 7, and then divided by 3, like that. Here. So we know that OC divided by OD is equal to 7 over 3. So here I'm going to let our OC is equal to some constant 7k, and then our OD is equal to 3k, and then this k should be greater than 0 since length, they are length units. Yeah, OC and OD, they are length units, so they can be negative. So conclude that they also cannot be equal to 0. So conclude that k is bigger than 0 here. So I'm going to label this OC as our 7k, and then our OD is equal to 3k here. So the area of triangle COD is equal to 21, and then here we are going to use the formula, which is 1/2 AB sine C, right? So we can use our 1/2 times 3k times 7k times sine 30 degrees is equal to 21, and this is the formula, 1/2 times AB sine C, which is equal to 21. Its area is equal to 21. So here we are going to get 3 times 7, which is 21, right? And then our sine 30 degrees, which is equal to 1/2. So 1/2 times 1/2, we are going to get 1/4. And then times 21k squared is equal to 21, like that. And then 21 and 21, they cancel each other, so we can get k squared is equal to 4. And then k, we can get k is equal to 2 or -2. And then we are going to reject k is equal to -2 since k is the ratio. So ratio between OC and OD is equal to 7k divided by 3k, and then this k should be greater than 0, so we are going to reject k is equal to -2. So here we can know that our ODC, this is our triangle ODC here, and then our OD is going to be 3 times k, which is 3 times 2, which is equal to 6. And then our OC is equal to 7 times 2, which is 14. And then we are going to find the length of CD here. And then we know that the angle, the area of this triangle is equal to 21 square units. Right. So here, how can we find the length of CD? And then we can find it without knowing this angle. How can we do that? Yes, you can try by using the sine law or cosine law, but here I'm going to try by our Hilbert formula, trying to find this CD length by using the Hilbert formula. First, Hilbert formula tells us to add this length together. So I'm going to use a simple here. Yes, we are going to name this CD as our A. So our sine S is equal to 14 plus 6 plus 8 divided by 2, right? So S is going to be 20 plus 8 divided by 2, like that. And then here, use our Hilbert formula, we can get our area is going to be, first thing, you're going to use this S to multiply by this thing minus 6, and then 20 plus A over 2 minus 14. And then finally we are going to use 20 plus A over 2 to minus A here, which is equal to our 21. After some steps and cancellation, you are going to get equations like a power of 4 minus 464 a squared plus this thing is equal to 0. And then you are going to get two results here. One is a is equal to this, and one is equal to this. And this is approximately equal to 9.30, and this is approximately equal to 19.4. And which one should I take? And this, we should not have two results, because look at this. This is 6 and this is 14, and its area is equal to 21. And these two lengths are constant, so this CD should be a constant as well. It should not have two answers. So here, what can we do here? If we put 9.3 here, let me use our calculator. 9.3 plus our 6 is equal to 15 plus 3, and this is definitely greater than 14. So this is acceptable here, right? And then use this plus this. And if this is 9.3, 9.3 plus this is gonna be 15 plus 3, which is greater than the longest length. And if this is 19.4 and this length plus this length is equal to 20, which is greater than 19.4, which is known as the longest length of a triangle. So this triangle equality is true, so we cannot use this. So which value should I take here? Sure, I think this is a problem here, but this kind of easy. So let me try to draw 6, something like 6 here, and then here something like 14 degrees, like 30 degrees, like that. And then OD is equal to 6, and then OC is going to be 14, and then this hypotenuse, this not called the hypotenuse, I don't think so. And this the A we are going to find. Look at the ratio, and you can see this A cannot be equal to 9.3. So we are going to take this A is equal to this. Therefore, we can conclude that our CD is equal to our 2 times our 50A plus 21 times square root of 3, and this is our result. A really cool result.